So we're talking about slope as a rate of change. So when it comes to linear relationships, a linear relation describes a relationship in which the value of one variable depends on the value of another variable. So the example we have is very similar to the one we saw in our quiz last week. A cell phone plan costs $40 every month plus 15 cents to send or receive a text message. The total cost of your plan depends on how many text messages you use per day. So this situation can be modeled using the formula, or we may have seen this before from last year, y is equal to mx plus b. So that is our equation for a linear relationship, where we let y represent the total cost of the cell phone and let x represent the the number of text messages. So the equation that represents the situation would be our total cost is equal to 0.15 or 15 cents per text message plus our $40 base rate, or our $40 per month. Our table of values, so we're going to use our equation to complete the table of values. Well, when there's zero text messages, how much is it going to cost for our monthly plan? Well, there's no text messages, so therefore it is $40. When we have one text message, we know that it is $40.15. How much does it cost if we have two text messages? $40.30. And all I'm really doing is I'm taking the equation up here and I'm plugging in my x value, these numbers. So when I take the number 1 and I plug it in to this x value, well, 1 times 0.15 is just 0.15. Then I add 40 to it and I get 40.15. When I have two text messages, I plug in 2 to the x value. This becomes 30 cents. 30 cents plus 40 gives me $40.30. And I keep plugging that in, so I'm left with 40, 45, and then this is $40.60. So we're talking about the rate of change, or the change of the y values, pardon me. So what is the change between this y value and this y value? Well, we can take our $40.15 and subtract 40 from it, and we would get 0.15. Same thing here. We take $40.30, and we subtract $40.15, we would get 0.15. And we would do the same for every step. We would notice that the rate of change is the same, or constant. Looking for that constant rate of change. When using our table of values, graph the data set to show the relationship between the number of text messages and the total cost of the cell phone plan. So connect the data points and then describe your graph. Okay, so I'm going to connect my data points. Well, I know my first data point, how many text messages, the number of text messages. When I have one text message, how much did it cost me along the side here? Well, I know that it cost me for one text message. If I actually look up back to my table of values, one text message cost me $40.15. So when x is 1, my y value is $40.15. And that would look, when x is 1, y is $4.15. When x is 2, it cost me $40.30. When it was 3, it cost me $40.45. And we're just simply plotting these on the graph here and then putting a line through it to graph this relationship. What do we know about this graph? It is a straight line. Straight line. So to find the rate of change, choose any 2 points on your graph and label them A and B. So my first point, I'm going to label this as my A point. Well, what's my X coordinate? 1. What's my Y coordinate? 40.15. And then I'm going to label this point here as B. And my X value is 3. And my Y value is 40.45, comma there. So when I write down the coordinates of my points, point A, I'm going to go, yeah, a little point A here in yellow. The X coordinate and the Y coordinate in this point, we're going to remember as X1 and Y1, or our first X value and our first Y value. So I'm going to plot that in as 1, then 40.15. My second point B, I'm going to remember to be X2 and Y2. So my second point for B, my X value is 3, and my Y value, 40.45. Finding the difference between the coordinates using the 2 points, and between the 2 points using this formula, where M is equal to Y2 minus Y1 over X2 minus X1. So this M right here is the symbol we use for slope. We just use the letter M. So in this case, what are my values? Well, my Y2 value is here, and I'm going to subtract my Y1 value. So I have 40.45 subtract 40.15. 40.45 subtract 40.15. All over my X value, or X2 and X1, in this case would be 3 minus 1. Well, I know 3 minus 1 gives me a value of 2. And then 40.45 minus 40.15 is 0.30, which when I take 0.30 and divide it by 2, what do I get? Well, I get 0.15. So using our slope formula and taking 2 points along the line, we can calculate the first differences, or the rate of change. So how does this value compare to the rate of change you found in the table of values? Well, it's the same. It's the same. So our rate of change, and I already kind of hinted to it before, is also called slope. The formula for slope is M is equal to the rise over run, or equal to the second Y value minus the first Y value over the second X value minus the first X value. So the rise is the vertical distance between Y coordinates. The run is the horizontal distance between the X coordinates. So in summary, we can determine slope in 3 different ways, right? So we have the equation. We can plug it in for the equation on a certain cell phone, cost for the text, so we know that the actual rate of change is going to be 0.15. Table of values is our second way that we can use. We can determine our slope. So we see that here where we had number of text messages, and then we plugged it into the equation, we get our values, and the rate of change, or the difference between all of these points, we discovered to be 0.15. The third way we can do it is using a graph, and we calculate the slope of the line by using rise over run, or y2 minus y1 over x2 minus x1. And we have our point here and here, and we just figured out the rate of change between those 2 points. So if we were going to try it outside of those 2 examples, we have a line here, that is, our first point is at 1 and 3, and our second point is at 7 and 5. We're following this formula. So I'm just keep writing this in a different color here. We're going to use y2 minus y1. Well, in this case, it would be 5 minus 3. 5 minus 3. Our second y value minus our first y value over our second x value, which is 7, minus our first x value, which is 1, which would give us, well, 5 minus 3 is 2, 7 minus 1 is 6. If I could reduce that, 1 over 3. So what we can say is that the rise is 1, the rise is 1, the run is 3. So the rise in this case would be 1, the run would be 3. Now, if we were to look at this literally, it would probably make more sense that we could see 2 over 6, right? We can see that it went up 2 and went over 6, but we reduced it to 1 over 3. So that is how we would be calculating the rate of change or slope as a rate of change using 3 different